Okay, today we're starting into Chapter 8, Exponents and Exponential Functions. And you'll also notice that on this sheet it says that we're going to learn about scientific notation. This is the right time to do that in the exponent section. And then we'll definitely cover some exponential functions, and that's one of the things we'll talk briefly about today. So here we go. So first section, 8.1, we're going to cover 3 today, 8.1 through 8.3. 8.1 is on properties of exponents using multiplication. Alright, so an expression like 4 to the 6th power is a power, and the 4 part is the base, the 6 part is the exponent. And so when we have an expression like 4 to the 6th power, that's like taking 4 and multiplying it by itself 6 times. That's how exponents work. The first of the power rules that we're going to learn is when you multiply two like bases. So here we have a to the m times a to the n. The like bases are a, and the exponents are m and n. So when you multiply like bases, you add the exponents. So like bases in a to the second times a to the third, a is the like base, and so you're going to add the exponents. 2 plus 3 is 5. Here we have another example. We have 4 to the 5th power times 4 to the 3rd power. 4 is the base, so we add the exponents. So it becomes 4 to the 5 plus 3, which is 4 to the 8th. Now if you have a problem like this where it's 4 to the 8th, I'm happy to have you leave the answer like this and not pull out your calculator and do the multiplication for me. So here we have our second power rule, and this is when you take a base a and an exponent m to the power of n. And when you take a base and an exponent to a power, you multiply the exponents. So here we have 5 is the base, 2 is the exponent, and 4 is the power. So we have 5 to the 2 times 4, which is 5 to the 8th. Another example, x to the 3 times 4 is going to be x to the 12th. X is the base, 3 is the exponent, 4 is the power. This is the same power rule for me as the one before it. You're still taking a base a and an exponent 1 to a power of m, and a base b and an exponent 1 to the power of m. So you're going to multiply the exponent by the power. The exponent 1 times the power m. So this one is going to become 3 to the 4th times x to the 1 times 4 times y to the 1 times 4. Now when you get a number like 3 to the 4th, that's a number that even I can, 3 times 3 is 9, times 3 is 27, times 3 is 81. So that would be a number that I think is small enough to write as 81 instead of a 3 to the 4th as an answer. And if there's any kind of a real question here, I'll err on the side of being easy on you rather than hard. Now this is an order of operations problem. This is where you have to combine rules. So we have bases and exponents to a power, and we have being multiplied by another exponent. So we're going to have 3 squared, and x to the 4 times 2, and y to the 1 times 2, and then we still have that y to the 5th. So 3 squared is 9, x to the 4 times 2 is 8, and then you get y to the 1 times 2 is 2, and then when you multiply like bases you add the exponents. So 2 plus 5 is 7. So those are the 3 different power rules that we've learned so far, and those are all in section 8.1. 8.2 gets us into 0 and negative exponents. And I like to say, if we're going to memorize this rule, anything to the 0 power is 1. Obviously, you can't say 0 to the 0 power is 1, so a can't be equal to 0, but anything to the 0 power is 1. And I like to say this rule is you're not allowed to have a negative exponent in your answer. So you're going to have to take that negative exponent to the other side of the division bar and change the sign of the exponent. So if you have a to the negative n, you can't leave that as an answer because it has a negative exponent. So you're going to take the base a and the negative exponent, negative n, take it to the other side of the division bar and change the sign to positive. So here we have 3 to the negative 4 power. Again, you're not allowed to leave a negative exponent, so we're going to take that to the other side of the division bar and change the sign of the 4 to a positive 4. So the 3 to the negative 4 becomes 1 over 3 to the 4th, and 3 to the 4th is 81. Here in this problem we have negative 5.2 to the 0 power. Anything to the 0 power is 1. Again, a negative exponent. It's okay to have a variable as an exponent. This just means the base and exponent go to the other side of the division bar and we change the sign to positive. So the negative y becomes a positive y when we take it to the other side. This is a problem that we see a lot, and working it out, what ends up happening is you take that 3 and the negative 1 gets applied to the 3 and the negative 1 gets applied to the 5, and so you end up with 3 to the negative 1 power over 5 to the negative 1 power, but you're not allowed to leave a negative exponent. So you take both of them to the other side of the division bar. And the easiest way to think of this is whenever you get something to the negative 1 power, you're going to write the reciprocal. So we're just going to write the reciprocal of the fraction here. Now here you have a 4 with a positive exponent and a 3 with a negative exponent, so only the 3 and the negative exponent go to the other side of the division bar. The 4 stays in the numerator because it has a positive exponent. Again, the same idea here. The 5 has a positive exponent, the g a negative exponent, the h a negative exponent. So the g and h go to the other side of the division bar and you change those signs. And that's how we deal with negative exponents. Here, we're combining from the very first section, 8-1. So when we're multiplying like bases, we add the exponents. So 4 to the negative 3 times 4 to the positive 3. We're going to add the exponents, and you get 4 to the 0, which is 1. Here, you take a base and an exponent to a power, you're going to multiply the exponents. And negative 2 times negative 3 is positive 6. Again, if you just wrote 5 to the 6th here, I would be happy. You would not have to pull out your calculator and do this for me on a test. Again, a negative exponent. So we take the 2 to the negative 3 to the other side of the division bar. It becomes 1 over 2 to the 3rd, which is 1/8. Here, both of these numbers are going to have the negative exponent applied. So both the 4 to the negative 3 and the y to the negative 3 will get taken to the other side of the division bar and made positive. All right, so those are our examples using those power rules. And now we're going to touch on exponential functions. And the form of exponential functions is this function form of y equals a times b to the x power. Sometimes you'll see this as f of x equals a times b to the x power. When we're going to graph an exponential function, we're just going to use plug and chug. We're going to plot points. So here we have y equals 4 to the x power. We're going to plug in a negative 1 is our input, and 4 to the negative 1 power would be 1/4 because you take that to the other side of the division bar. When you input 0 in for x, you have 4 to the 0 power, and anything to the 0 power is 1. So we get 0 and 1 as one of the points. We plug in a 1 for the x, and we'll have 4 to the first power, which is 4. And plug in 2 for the x. 4 squared is 16. We're going to go off our graph at that point. And here we're going to draw a smooth curve, and there's our function. And really, that's all we're asking you to do in 8.2 in terms of functions today. Just plug and chug. So we get in 8.3, which is division of exponents, and it's just more power rules. And I would tell you right here that if you take 2 like bases and you're dividing, you're going to take one of the base and exponents to the other side of the division bar and change the sign. The n is positive. That's positive n. So when we take it to the other side of the division bar, it becomes negative n, which is very much like the power rule we just covered. In this example, 4 to the 5th divided by 4 to the 3rd, you'll see that you'll take the 3 to the other side of the division bar, and it becomes a negative 3, and that's 4 squared. Sometimes I like to show that really all that's happening here when you have 4 to the 5th is there's 4 multiplied by itself 5 times in the numerator and 4 multiplied by itself 3 times. Well, those things are going to cancel. We've all seen that canceling before. So that's how you end up with 4 squared in the numerator. Alright, so here again we have the same power rule we just covered. So we have an a over b in the parentheses and the exponent's m, so that m gets distributed to both the a and the b. When we have 4/5 to the 3rd power, the cube goes to the 4, the cube goes to the 5. Again, if you left your answer like this, I'd be happy. When we divide like bases, we're going to take the smaller exponent to the other side of the division bar and change the sign. So this becomes 4 to the 5 minus 4, which is 4 to the 1st power. Again, combining rules, in the numerator, we have multiplying like bases. So the numerator becomes 6 to the 3 plus 5, and the denominator is 6 to the 9th. So we end up with taking the 8 from the numerator down to the denominator and subtracting it from the 9. And that's why it becomes 1/6. Here the x squared is actually in the numerator. It may not look like it, but it's x squared over 1. So we have an x squared in the numerator, we have an x to the 4th in the denominator. The 2 from the x squared comes down and subtracts from the 4. So we have 2 over x to the 4 minus 2, which is 2 over x squared. Again, the 3 gets applied to the numerator and the denominator. So we have 1 to the 3rd and 4 to the 3rd. The negative exponent means we're going to do the reciprocal. And so the 2 to the negative 4 becomes 2 to the 4th in the numerator, and the 3 to the negative 4 becomes 3 to the 4th in the denominator. And here's our last example problem. Alright, in this problem we have multiplying to do and dividing to do, and really the easiest way to do this for me is to start with numbers and work across each number separately and each variable separately. So the first thing I see with the numbers is that the 4 will divide into the 12. So I'm going to cancel the 4 into the 12, and that's going to go 3 times. So I'm going to have 3 times 3 is 9 in the numerator of my answer. And then when I go and do the y values, or maybe I'll do the x values first. So I have an x in the denominator here, and so my x in the denominator is x to the 1st. It'll cancel into this little 2 up here and make that 2 a 1. So I'll have x to the 3rd times x to the 1st, and that's going to be x to the 3 plus 1, which is x to the 4th in the numerator. And then in the denominators, when I start looking at the y's, I've got y cubed in the denominator, and I really have y cubed in the numerator. Because when I multiply these like bases, I add the exponents, and so the y's become y to the 0 power. Alright, so we end up with 9x to the 4th in the numerator. And that's it. That's sections 8.1 through 8.3.